You're listening to Made for IoT, a podcast celebrating the leaders, innovators, and disruptors of the Internet of Things, from hardware to connectivity to cloud. For more insights, make sure you visit Onomondo.com.
Hello, everyone, and welcome to this webinar where we're going to talk about maximizing IoT device coverage, and we're going to look at hardware and software perspective. We're going to talk about a bit of this and that, and also dive into real-life examples. And I'm just going to jump to the next slide and present an awesome guest that we have today. It's Chris Guest from Lightbug, our most dearest customers using Onomondo every day. And we're going to cover a few topics today. We're going to look into technology selection. We're going to look into hardware optimization, and then we're going to look into software and network optimizations. But let's start out by introducing ourselves. And Chris, do you want to go first?
Sure, yeah, thanks, Henrik. So, as it says on the slide, I'm Chris Guest, founder of Lightbug. Lightbug, we're a full stack IoT business. We do hardware, software, and for us, just achieving the end goal is all that matters. So, and coverage is a huge part of that. If you don't have a device that can't send data, then it's basically useless. So, really today we're trying to get across some of the knowledge, some of the things we've learned over the past 10 plus years deploying IoT devices, and hopefully help a few people out.
Perfect. Thank you for that. And my name is Henrik Agard. I'm CTO and co-founder at Onomondo. And Onomondo, we are a tech company. We do software. We build software, and we use that within connectivity to optimize, you can say, IoT devices' everyday life. We try to be open and transparent, and really utilize the technology that is out there. So we're going to go through a few different topics. And the first one is technology selections, and then we're also going to open up for questions during the presentation. So feel free to jump in the chat and ask whatever you might have, questions or comments or whatever, as we go through these ones. I think one of the first things that is interesting to discuss when speaking of IoT is choice of connectivity. So there are, of course, a lot of different types of technology out there. There's LoRa, there's Wi-Fi, there's Bluetooth, there's cellular. And there's no doubt that, of course, within Onomondo, we've gone the cellular route for now. The reason we've done so is that it's globally deployed. It's available, it's standardized, and the sheer fact that it's licensed also gives us a guarantee that it's gonna exist for the years to come, which is one of the most important factors when it comes to IoT devices. The fact that you deploy devices that's going to last for 3, 5, 7, 10 years, we need to be sure that the technology we choose also exists in the years to come. And Chris, your point on sort of selecting technology and how have you gone about that?
Well, so you mentioned license spectrum here. You have a really good point about the longevity of it, but from our point of view, it's also it's a hardware, it's a power thing. If you've got a licensed spectrum, it means that everyone in that RF spectrum is behaving according to some rules. It means that you can transmit more power, and it means you can get coverage, not just in more places, but in more situations. So if you're underground, inside buildings, things along those lines, it's hugely helpful to have a standardized technology that is licensed, that you know that there's not going to be any noise, and just that sheer choice of cellular is already helping to maximize that connectivity piece, ensuring that you can always connect. And you've talked about the future, but also globally, it's everywhere. It might be different technologies, but largely you can connect a mobile phone in most habited places in the world. So you're already onto a winner with cellular.
Now, you already mentioned that it's globally deployed, but there might be a few different technologies, and I think this is also where we put in the keywords of GSMA standards. I think one of the, as you mentioned, the beauty of cellular is that it's globally deployed. But one of the challenges can then also be, you can say, the amount of different technologies within that realm. We have GSM, we have 2G, 3G, 4G, upcoming 5G. We have the new low power wireless technologies, NB-IoT and LTE-M. Is that hindering, you can say, the global deployments? Or how do you view that?
It makes things difficult for sure. It's helpful in some sense. It means that we have a large choice, but at the moment it feels somewhat like we're in between. We're almost on the cusp. You mentioned like low power technology, NB-IoT, Cat M1. they feel like they're almost there from our point of view. So we still ship our products with 2G connectivity because it ensures that it will always work globally. But 2G is sort of power hungry. We'd like to get rid of it, but it's still around so it does cause problems. But I think in the next probably 5 years, things should standardize quite a lot. And we should see sort of new standards come in, also start replacing things. And generally what we're seeing is everything's moving in the right direction, just a bit slower than we'd like.
Yeah, I think we can agree on that as well. I mean, we are a global operator, and we touch, I think it's over 160 countries every day. And what we also see is that definitely for sort of global deployments, you still need to rely on, you can say, 2G as a fallback for now. Hopefully, as you mentioned, that's going to change in the next 3 or 5 years. We're seeing heavy sort of speed up in rollouts of NB-IoT and Cat-M1. But nevertheless, at the end of the day, you need to still rely on sort of the older technologies. Have you ever sort of come into more nationwide deployments where you could optimize even more, and then you can say leave out sort of the global aspect, but still then had to sort of go in and optimize for specific regions or countries?
Definitely. So it's quite common that we tend to get deployment in the EU or just in the US. When it's just the US, I mean, they've turned off 2G, so we know we can go with Cat-M1. NB-IoT over there isn't amazing, and more generally, we find NB-IoT to be quite challenging with roaming and just general global deployments. But in terms of optimizing for local areas, it's definitely something we can do. We don't go down that route for our off-the-shelf devices just because we like to have a single product that can work anywhere. But when it comes to more of the custom developments that we do, absolutely, we tend to optimize. And it's just, if you can take out technology, you're cutting out costs, you're improving already the performance of the device. So we do tend to do that. I actually had a question to you just said about NB-IoT and Cat-M1 being sort of deployed globally. Have you found it's an either or is it a bit of both? Or is it always both the same?
I think we definitely saw in the beginning that parts of the world were sort of more leaning towards Cat-M1, and other parts of the world are more leaning towards NB-IoT. And I think there can be many reasonings for doing so. Time to market, technology, the vendors, the MNO or the radio access network operators have. What we do see now, luckily, is that you can say the majority of MNOs are deploying both type of networks. I think one of the fascinating things about NB-IoT and Cat-M1 is that it's been accepted as part of the 5G stack, and so there's a 20+ year lifetime guarantee on it. So the support is definitely going to be there. But there's no doubt that I think, even though, again, going back to cellular is globally deployed, we are still dealing with a lot of independent networks. And we are relying on those independent operators to deploy the technologies with it that well. I think that also sort of lead the way into a few of the last topics on this slide is steered SIMs and the UICC versus UICC solution. I think in our realm, you can say there's a lot of talk about having the amount of networks that you have. You have 300, 500, 700 networks. And we in Onomondo is also, you can say, putting marketing out saying we have 700 networks. I think one of the things that is very important to then also understand is how the technology then actually works on the SIM and towards the device itself. And we've come across that there are two main factors that speaks into how the device behaves and see those networks available. And one is steered SIMs. I think in the majority of time, there's going to be a preferred network list on the SIM due to commercial reasons. And we have the mentality of saying that it's up to the device or to, you can say, our customers to get the best quality of service there is out there, selecting the networks that's available. And we've had cases where there was steering on the SIMs that we shipped out, and there we definitely saw a lack of quality of service. We saw retransmission escalating and others. So we do see sort of real life impact when you don't allow devices to get the best quality of service. And then flipping it over to the whole UICC versus EUICC talk. I think it's been very interesting the last few years to sort of see EUICC and eSIM taking off. It's been mentioned as sort of the savior towards IoT because this realm is lacking, you can say, the industry working together. But at the end of the day, I think the UICC discussion is also how you view the architecture or the design. Where going about the UICC, that's sort of coming from an infrastructure perspective. You want to allow the device to not change behavior wherever it goes, while the UICC route is more an over-the-top solution where you then jump between networks. And I think from a device perspective, that seems like pulling out the SIM and putting in a new one, pulling out the SIMs and pulling in a new one. What's your sort of experience both with the topic of steered SIMs and then the whole UICC versus UICC talks? That's very much ongoing these years.
Yeah, so in terms of steered SIMs, our first experience in the world of IoT was with steered SIMs, and it's something even more fundamental. So you've mentioned like issues with transitions, things like that. We had issues that the SIMs just weren't failing over, and so the steered SIMs, they use an onboard logic that require the cellular modem to interpret the commands to do something with that steering, and the modems that we were using from a pretty well-known manufacturer just weren't working. They were ignoring the steering commands. And so what ended up happening is that we would just have devices that would stop connecting, and they would need to have like a physical reset or a physical input, which in the world of IoT is just really a bad thing. So allowing, I 100% agree that keeping the hardware as basic or as simple as possible just means that you reduce the risk of error. So in terms of having unsteered SIMs and leaving the logic somewhere else, it has a huge impact on us, just from a hardware and support perspective, in that we know that when a device is turned on, it will connect to any network that's out there so long as we've configured it. And it's hugely powerful because we can change that on the fly when it's unsteered. If it's steered, then we're kind of locked in. You might be able to change it with some device firmware updates, but it's a lot of work and it introduces a lot of bugs. To move on to the UICC, the eSIM side, from our point of view, eSIMs were not a solution for customers. They introduced headaches, and as you say, it's just like pulling out a SIM card, putting in another one from the device perspective. From our point of view, it feels like it's a commercial solution to the issues that have come about with permanent roaming on a global scale, and it's not a connectivity solution. From my point of view, it is a commercial one. It allows you to get local rates, local or better rates, better connectivity, maybe in some areas where sort of agreements aren't so readily available for international customers. But in our experience, they've never been worth the effort. And actually, one final thing is that they have compatibility issues. So sometimes they work, but quite often they require a specific cellular modem that will accept eSIMs.
I fully agree on that, and I also think, I mean, UICC definitely to some extent has sort of this more sort of in insurance mentality than providing better coverage. But what I also fear right now is sort of the tendency we see that right now we have UICC UICC M2M and consumer versions, and now there's been working on the IoT solution, which is going to combine, you can say, the best of both worlds. So it's a very new space where I think we need to also give it the time to really see sort of the effect that it might have. I'm just quickly going to jump to sort of the questions for this. We have a question from the audience on, won't UICC SIMs making keeping track of SKUs more difficult? I have, of course, you can say my opinion on it coming from Onomondo, but sort of what's your opinion on that?
Well, I think it's the same as yours in that it's one of the reasons that we chose Onomondo is that it says UICC SIM, but we still don't need to have multiple SKUs. It's a single SIM that will work globally. But more generally, though, the question is perfectly valid. Yes, it would in other cases make keeping track of SKUs more difficult, in that if you have to fit different SIMs to different devices that are being shipped different places. I mean, this week I've made that mistake once where I shipped a device with a different SIM card, and I had to ship out a replacement and arrange for a collection just because I'd forgotten that it was the wrong SKU. So it happens to the best of us. So it is absolutely normally an issue, a traditional issue, I'd say, with UICC, but you guys have solved this one pretty well, and it's working well for us.
And I think actually there you touch upon a very vital thing that you had sort of to go out and do a replacement. And I think one of the most vital things specifically within the IoT industry is that our finest job is to make the hardware work in whatever situation. As soon as you need to touch the device, I would assume that sort of the whole commercial model for that single device is pretty much broken. So from us as an operator point of view, we really go a long way to design it around the device. That's at the end of the day, to some extent, our customer, or at least sort of our technical customer. That's the devices, and I think there it's very important to go very, very far to make the right solution.
No, that makes perfect sense, and it shows from our point of view.
Perfect. Let's jump over to the next topic, which is sort of on hardware optimization. I think this is definitely a part that you're way more experienced in than us as the operator, although we do have quite a big interest in this realm. But when you go about and design hardware, you mentioned you want to work also with a single SKU on sort of the hardware piece, where you don't want to design dependent on the use case. How do you start? What's the challenges? What pitfalls? And also maybe what mistakes have you done in the past, but then also solved?
I think this webinar's a bit too short for the list of mistakes, but with regards to how we go about things, it's always about the use case first. So we start with general, really basic things like what is it tracking, where is it going to be, how big can the device be, and it sounds really, really simplistic, but really the bigger the better on the antenna side. So what we try and get out of customers is, well, how big can we make this device? Does it matter if it's the size of a lighter, or can it be the size of a brick? Quite often, actually, the answers surprise us in that people don't tend to care too much about size. Sometimes it's really critical, but that's the first place we start, is how do we maximize antennas, so reception, the free space around the device in order to maximize that coverage piece. And for us, that kind of ties into positioning. So if you've got a bigger device, it probably means that it's in an area with more space, so it might have less interference. But then conversely, if you've got a small device, it might be tucked into a small metal case or something that might be blocking the signal. And so those two first points for us are very critical. And we tend to say, obviously, the bigger the better. I've said that, but when it comes to using it, we appreciate that that's not always the case. Sometimes devices need to be hidden for them to serve their purpose. They're anti-theft devices, they're deterrents, or they need to fit within a certain flight case. At which point we start looking at how do we optimize positioning. And again, some really fairly obvious, or maybe top level stuff is, devices don't like being near metal. So if you put the antenna or a device near, you're not even in a metal box, but near a big metal object, you're going to degrade your performance. And really the key factor that we've seen that's turned around our sort of pilots from a high failure rate to success rate has been providing guidance on where to mount our devices, how to use them. And I think we're all really used to having cell phones that work everywhere and anywhere, but they've had sort of millions of pounds spent on developing those antennas, tuning them, making sure that they always work. There's been a few sort of high-profile issues when, I think it was the iPhone, I can't remember, where they were using them with their left hand and it was blocking the signal. Those kind of things, we don't have the budget of Apple, but we still need to solve those problems. And those things really should be top of mind when you're thinking about an IoT deployment, is how do I give the device the best chance at seeing the network, let alone connecting to it.
It's very, very interesting. And I mean, just going back to another thing that also mentioning antennas, I think right now you're going about with NB-IoT, LTE-M, and fall back to 2G on the module side. We're seeing a tendency now in the industry on putting LTE Cat 1 bis into sort of into the bigger market, and I think when we speak to radio module manufacturers, I think it's due to the lack of deployments within NB-IoT and LTM. It's simply taken, you can say, too long time for these deployments to go global. Where the interesting thing about Cat 1 is, whenever you have an LTE network, you do have Cat 1. We also have customers traversing the globe every day that's gone about that route. Then to our understanding, one of the downsides with regular Cat 1 is that you often needed to have multiple antennas, where then the Cat 1 bis, you can go about only having one, which is cheaper on bill of material and then also on hardware design. Is that something you've come across or you heard about?
No, so Cat 1 bis, to be honest, we've kind of left it until it's sort of deployed more. I don't know that much about the bis. Could you just explain what the core differences are? So it sounds like it's the same frequency, different. Well, I'll let you talk.
Yes. No. So as mentioned, so Cat 1 has existed for quite some years, but nevertheless there are new LTE releases within the categories already deployed, and then Cat 1 bis is I think it's release 13 or 14 and upwards that is then dubbed as Cat 1 bis. So it's still the same category 1, it's still the already existed deployed LTE network, but Cat 1 network, but you're sharing more spectrum, etc., so you can go about with one antenna. And again, it's maybe also to touch a bit upon sort of the whole cellular talk, where again we are sort of profound fans of that technology due to that it's globally deployed, etc., as we touched upon earlier. But it's also still the effect that we're seeing the industry not working together, that now we then have a new technology just after NB-IoT and Cat M1 slowly being marketed. And there I think it's really, really interesting to also maybe touch upon on how that might stop some use cases, because customers or projects may have a tendency to want to wait and see the future, or what the future might hold, because we are always seeing new technologies. Again, repeating on, we had LTM, Cat M1, now we have Cat 1 bis. On the SIM side, we have UICC, EYCC, M2M, EYCC consumer, and now EYCC IoT. So I think from my personal sort of understanding, I could imagine that it could be quite difficult to make the right decision. Whereas I think we as the operator, we need to pay respect to the industry and make it as easy for projects to really take scale. And one of the things I'm a very big fan of what you guys are doing is you just get going. You just go out there and you're actually solving stuff and building stuff today and are rolling out devices. So maybe sort of in a broader term than just Cat 1 bis is more, how do you go into when new technologies arrive in this realm, and how do you make decisions on what to put into production when you do rollouts or products?
Sure. Well, from our point of view, it's a pragmatic approach. If it's available wide enough or available in our target markets, we'll put it in. If it's not available, we'll work around it. So I think my sort of favorite example is the power saving modes on NB-IoT and Cat-M. Those have been slated to really improve IoT battery performance and all that. But from our point of view, it's not well enough deployed that we can't rely on it, and therefore we shouldn't use it. It might work well in the UK, but then it might stop working when it goes to Denmark. In those cases, what we tend to do is just take a step back, and where appropriate, where it's not the industry having standardized, we'll take an opinionated view. So we'll say, right, we don't want NB-IoT, we don't want PSM modes because it's not working, but we still want the advantages of what's happening, and so we'll try and work around it. And so it really is, as you said, it's a get up and get going approach. We take what we've got and try and get it working. And I think maybe 5-10 years ago we would have really struggled, but now it's at a state where it's good enough, and good enough. I mean, that's all that we really need for IoT, for something that's sort of cost effective, efficient, works reliably enough. To us, that feels like it's only really happened in the industry in the last 2 to 3 years, but it's getting there. So try not get too caught up with the Cat M1 bis. Those things, like, I'm not too worried about them. When they're available, they'll be available to our customers, and that's the way we'll approach it.
As mentioned, I'm a big fan of that approach. I think in respect of time, I really want to jump to the questions because we have a few questions coming in, and I think this is for you to answer. So the first one is, what kind of antennas do you prefer? Example, PCB, chip, or external antennas?
External antennas, always, if they're at all possible, we'll go for external. You'll always get the best signal on there, just because they're away from the internal components. Secondly, we'll go for PCB, and chip is our last. The reason that we don't like chips is because they're normally super highly tuned and they have very highly specified ground planes. So if you deviate at all from the manufacturer's guidance, which you almost always have to, it's a whole retuning exercise. And just because they're so intolerant to detuning, like you add plastic on the chip ones, they'll detune, you'll need to retune them. We're just a fan of the bigger the better. Like I'm going to repeat myself really. The more 3D space you can occupy with your antenna, the better the coverage. Chips are small by design. PCB, you can make really big traces, so that tends to be okay. But external antennas are always the best way to go, in our opinion.
Thank you for that. Another question that's come in is, how do you recommend robustness testing for coverage on devices?
So there's a lot you can do. What we tend to recommend for our customers is, I think it's a 1% volume, 10% time test. So if you're deploying 1,000 devices over a 12-month period, you want to test 10 devices over. Put myself in a hole here. I don't know whatever that 10% is, but say a month. Now that's just like a high level, like try to have enough time to cover all the situations. Then in terms of what you do to the device, generally we just recommend push it until it breaks. So it might be a case of you put it inside a building, it continues working. You put it inside a building, inside a box, it can. So there's various things. It's really about sort of replicating realistic scenarios. We've got a lot of logistics and freight customers, and our devices work great when they're stuck on a container, except then the containers get stacked and then they're inside a big metal box that's impenetrable to RF signals. So it is generally about taking the worst case conceivable scenario or trying a pilot deployment and seeing when the coverage drops off, digging into that, just really, and it's a hands-on approach. You can always theorize, but at the end of the day, this RF stuff is more complicated than most of us can understand, me included. So it is just a question about testing it and seeing when it falls over.
Yeah, no, I fully agree on that. I also think one of the things that we really try to recommend customers, of course, we as the operator have one side, and then there is everything on the device side that also can go wrong. But I really think we encourage our customers to also try and deactivate all networks within the country and see how your device recovers, or when there's lack of that and it suddenly comes back. So we can really try and test those edge cases, because as you rightfully put it, there are theories and specification and such, but at the end of the day, this is physical assets that we're working with, and however they perform, that can change very much depending on the scenario that they're in. I think there's one final question for this topic before we go to the next and final one. As an IoT solution supplier, how can I ship a device with UICC/EYCC, and my customers around the world should be the contractors, which has to pay for the connectivity? I don't know if you have a comment on that, or that's more for me.
I think it's one for you to answer in terms of how Onomondo handles it, but just in terms of the question itself, it's something that we quite commonly come across, and we've got our own systems in place to handle it, but it is something that is difficult to handle, and I think Onomondo's got quite a nice solution for it, but I'll let you take over.
Yeah, I think it really depends, of course. I mean, we do have customers who are then, you can say, allowing their customers to pay for the bill, but at the end of the day, the agreement still lies with us. But we do also go about having customers where we actually transfer the SIMs or the ownership to other customers. And technically so, we've simply detached, you can say, the whole commercial aspects agreement on the SIMs from the customer's ownership, which to some extent is quite rare. But here we see those are two different things. So we really want to offer that flexibility where you can say that the ownership of a SIM can be transferred. I think with the EYCC route, there are multiple ways to go about it, and it can be quite complex. And I also think that's one of the reasons why EYCC might still lack, you can say, the traction that it was expected to have. And I think one of the reasons is within EYCC M2M is that you still have sort of a platform ownership of the EYCC or the EYCC RSP, as it's called. So it might be that you can transfer either, you can say, the MNO or the connectivity subscription, but there might still be a relationship between the SIM and the SIM vendor that you bought that from. And I think it goes back to sort of the complexity that we're seeing within an industry consisting of 700, 900, 1,000 different networks that needs to be seen as one. But at the end of the day, the way that we've gone about it within Onomondo is to say that the commercial aspects of a SIM is not directly tied to the technical aspect of it. So those things can be flexible and can be moved around. I think let's jump to the final topic for today, where we look more sort of at software and network optimizations, specifically mainly also how we try to attack it, and maybe a few words on sort of hopefully the benefits that Chris, you also see from it. But I think one thing is, of course, coverage and having the amount of networks, but another thing is also coverage to be more independent on either specific technologies or networks. And I think one thing that touches upon this is also, again, sort of the whole EYCC, the SIM itself. How can that jump between networks? Is it a solution that's built on the device, or does it come from the infrastructure perspective? And then there's also the whole, what do we allow you as a customer to do on your device, us being the operator. And I think for us, it's very important that the more we can see the individual base stations or the antennas out there as just pure base stations, and then having those combined into one single unified network, I think from a device perspective, going back to, we really try to design things around the device, the better, because that gives the flexibility to say, okay, a base station is being overloaded. You can't transfer any traffic, user plane traffic. There's too many retransmissions, etc. Well, then we can simply allow the device to jump onto the next base station nearby. The same things goes for technologies. I mean, you can also, one thing is to steer a SIM towards a specific network due to the commercial model. You can also steer it towards a specific technology. And I think there, we as the operator, we need to give that flexibility towards the customer, because we can't take a single decision across all use cases. That needs to be very much dependent on the specific use case and device in question. And I think that's, again, going back to the respect we need to pay towards the devices and how we design things. That's very much important. And in many cases, there is a lot of beauty in cellular. There are a lot of standards that really take this into account. But I think to some extent, because we have an industry where a lot of players don't work together, we are seeing sort of, let's refer to them as hacky solutions, trying to overcome that. But if we're actually reading into the specification, I mean, 3GPP, ETSI, etc., a lot of these things has been taken into consideration. And if we simply allow that to happen on the device, then we can actually provide, you can say, a very, very optimized networks at a global scale, both global and also nationwide.
I think that allowing piece is really quite important. There's things that just make sense, right? And when they're blocked by steering or some, like one of our things that we found with, say, steered SIMs or anything that resides on the device, if something goes wrong with the network and you're relying on the connectivity from the network to change the setting, then you've got a chicken and egg situation where you're kind of stuck. You can't fix the device because it's not connected, and it would connect if it was fixed. So what ends up happening is that you get these like bricked devices, which if the logic was on the network side, they wouldn't be bricked. And so that for us is really quite important. I think there's been cases where there's transient issues where, I don't know, say there's been a network in the UK where they like a whole provider. I think there's 2 or 3 main networks in the UK. If one of them goes offline, you lose a hell of a lot of devices and a lot of coverage. if they can just automatically switch to the next available one without having any kind of like logic, oh, I must stay connected to the last known network, which happens quite a lot and it's useful most of the time. But if you're able to get out of that mode to recover from faults, that already increases your coverage, because on a global scale, those faults are pretty common. I think there was a network where we had a few thousand devices and they all stopped transmitting. And it was just something to do with the internet gateway on that network. Or I don't 100% know what happened, but just being able to disable that network temporarily and re-enable it later when we'd identified the fault had been fixed, which just, we didn't have to do anything with the devices. And that in itself is hugely powerful, because you can react a lot faster. You don't have to wait for things to update and configuration to make their way through. It makes a big difference.
Yeah, I think we had sort of a similar case, which is, I mean, hopefully a limited issue, but still it's going to exist for a few years still. And that was actually where we had sort of a 2G sunsetting. And again, because we had the unsteered SIMs, we allowed the SIMs to simply swap network if we had a prioritized list on that SIM. At the end of the day, that would still attach to the GSM network, never get the 2G data session, and just stick onto that network. But being able to allow that to jump to another network that still had 2G, so the devices could survive a few more years, that really enhanced sort of the business model for that. But I think as still sort of maybe a final word on this slide is it's really about designing, towards the device, and really allow things to happen accordingly. I think sort of in respect of time, we really love questions, and a few are coming in. We would really encourage everyone to send questions to us at hello@onomondo.com. And there we will definitely answer those. Chris, do you have sort of any final words that you want to put in before ending this session?
No, so I think connectivity coverage is a huge and complex topic in IoT. So starting from real basics is very, very powerful. And if we can at all, with the work that we're doing, simplify IoT, I think it's going to be hugely helpful. And so there's a long way to go before it is as simple as it could be or should be. But yeah, I'm positive that we're moving in the right direction, and it's good to see.
Perfect. Thank you for that. I'm actually not going to put any other words. I think that was very well put. I think I want to thank all the viewers that attended this webinar, and Chris, of course, to you. Thank you so much for participating and putting in sort of your experience and real life examples into words. And I agree. I think together we can sort of really make things happen. And it's not as simple as it could or should be, but nevertheless, I think it's good enough to really get things going.
Definitely. No, thank you for having me.
Thank you all,
cool.
And take care.
I think we've got a question from Jason.
Should we? Sure. We take the final one.
Yeah, might as well, just quickly. Just in terms of the battery drain, you're absolutely right. Connectivity just comes at the cost of battery, so it's always a trade-off. Is how hard you try to connect. That's kind of what we do as a business, so I won't give too much away. But it absolutely is a valid concern.
Perfect. I think that was the end note.
Yeah.
Thank you so much, everyone, and thank you for joining me.
You've been listening to Made for IoT. Never miss another episode by following us wherever you get your podcasts. For full transcripts and slides, visit the link in the show notes or onomondo.com.